I learned something from them just about every day over the last 10 weeks. So I think, Allie, I think you should take it away.
Awesome. Thanks. I'll share my screen. Can everyone see that? Okay. Hi, so we're the Sandcastle team working on a historical city builder. I'll just to introduce the team. I'm Allie. This is Jason, Renee, Jasmine, Jake, and Zane. And we just want to give a huge thank you to our project leads, Dave Zielinski and Ed Triplett. We also want to give a thank you to our stakeholders in art history, and visual studies, as well as the Office of Digital Humanities at the National Endowment for the Humanities. And just a little bit on what we're going to talk about today. First, we'll walk you through the historical significance of the Sandcastle Toolkit, then a little bit of what these past 10 weeks have looked like, the challenges we faced, as well as what we've accomplished, and then where we hope that the Sandcastle project will go in the future. And if you have any questions in the meantime, throw them in the chat and we'll answer them at the end.
So our project starts with the Book of Fortresses, which is a collection of castle drawings by a Portuguese squire named Duarte de Armas, who traveled along Portugal's border with Spain in 1509. Despite de Armas's attempts to create observational and cartographic images of each place on his itinerary, the book does not work in the same way as a traditional map. In the middle is a top-down map of castles and towns that de Armas traveled to and drew in the Book of Fortresses. On the left and right are examples of de Armas's perspectival drawings from the book. To create these images, it's thought that de Armas had to combine observations from multiple vantage points into a single image. To understand these spaces and his use of hierarchical scale, our task was to convert these 2D images into 3D computer-rendered spaces. In the end, art historians and historians of cartography will be able to use the toolkit we created to explore these images on their own terms, as spatial documents that were created before mapping became synonymous with a Cartesian grid.
The Sandcastle Toolkit was also inspired by large-scale exhibits such as Immersive Van Gogh, which has become very popular in museums around the world. These 3D spaces focus on a single art historical source, in this case, Van Gogh's Starry Night, and use 3D projection technology to help viewers immerse themselves in a work of art. However, these exhibits are professionally made and require months or years of work to put together. Our goal was to create a more simplified procedural system for users to turn similar landscape scale drawings and paintings into explorable 3D scenes. Our team's job was to focus on the translation stage of the Sandcastle workflow. This entails taking annotated features from the Book of Fortresses, such as towers, walls, hills, and more, that have been traced and classified in a previous stage, and translating these images into 3D scenes. We focused on developing a widely applicable system that can be used with any image that is annotated in the same way. Our project is called Sandcastle because we wanted the name to reflect the malleable sandbox-like computer environment that we use to create our 3D scenes.
So before we began training in our 3D modeling software and developing the toolkit, we developed principles to help guide us. These are the 4 most important principles that we tried to adhere to. The first was to minimize the scene builder's need to meticulously position and model each building of a complex perspectival map or city view. Next, we wanted to stay procedural and avoid randomization so scenes are specific to the images they represent. We also wanted to, wherever possible, make the process data-driven. The scene should always derive its information from the image, even if Duarte de Armas drew houses and towers that must be irregular in 3D. Lastly, we tested new features in the Unreal game engine early on in the process so we could make sure that the scenes look correct in their final form.
This is a quick overview of our project. So our first step was to familiarize ourselves with the software that we would be using throughout the 10 weeks. Then we created models in 3D of houses, towers, etc., and generated the 3-dimensional terrain. The third step was to produce the textures from our visual sources and procedurally map them onto our 3D models. And finally, we imported these models and the terrain into the Unreal game engine, first-person viewing. Houdini is the primary software we've used throughout the past 10 weeks. It's a 3D modeling and animation software that's commonly used in the video games and special effects industries. If you've seen anything made by Disney, Pixar, or DreamWorks, you've probably seen the work of Houdini. It's a visual programming software in which nodes or packets of code are strung together to create complex models and systems. You can think of nodes as functions that perform a simple action, such as changing the shape or color of an object. We used Houdini to create 3D models of houses, towers, walls, and terrains for our Book of Fortresses scenes. In the image shown here, you can see the Houdini interface, and on the left is a 3D model of a church that's being created and controlled by the nodes in the middle of the screen. One feature of node-based softwares such as Houdini is that the user does not need to always directly interact with code. Instead, they only need to know the purpose and functionality of the nodes they're using. But that isn't to say that you don't need to know how to code to make full use of Houdini, because you do. Throughout these past 10 weeks, we did a lot of coding with both Python and Vex, which is a C-like coding language that's unique to Houdini, to make our models and systems much more dynamic and interconnected.
While using Houdini, our goal was to make our models and systems procedural. In a procedural model, the attributes of the model, such as the height or roof angle of a house, can be changed without disrupting or breaking any other part of the model. Essentially, changes to one element of a model result in corresponding and compatible changes to the rest of it.
Using these same procedural principles, we created a terrain generation system that can be applied to any correctly annotated image. Our method uses the point outlines of the hills, which is data that was produced by the previous Data Plus and Fast Connections teams, and revolves these shapes about an axis to produce accurately shaped three-dimensional hills. As we created the terrain system, we had to come up with solutions to the various problems we encountered along the way. For example, you can see a cluster of houses in the image above. When the image was annotated, the hill behind these houses was outlined by going around the cluster, which resulted in what was essentially a hole or gap in the resulting 3D hill. And you can see this in the final terrain image in the bottom left. It's that gap you can see under and behind the house cluster. To address this problem, we implemented an individual hill generation option to allow users of the toolkit to add, shape, and control the placement of a hill with the click of a button. And you can see this on the right-hand side of the screen.
Part of the data that we started with for this project included traced facades of all objects from Duarte de Armas's 2D maps, as shown on the bottom left here. Our initial goal was to reconstruct these images on 3D representations of objects in his maps. So in order to get our image files for each object reapplied, we had to start with creating UV groups for our objects in order to apply each individual image file onto the correct face of a structure, as shown on the top left. A problem we ran into is that the map we're getting our images from is 2D, so that leaves back sides of our models without image files to receive, as well as empty spaces of sides with images, as displayed on the bottom right. This would ideally be layered on top of a tileable paper texture and would be applied to all things uniformly to account for gaps from images. However, after pushing the limits of the Houdini software to be able to not only compile these images correctly, but have them layered on top of another texture, we decided to take an alternative approach to texturing. So using the camera in our network, which Renee will talk about shortly, we were able to project the image of the entire map onto our architecture and then rotate those objects to align with the projection, which you can see on the top right of your screen.
So a camera with a user-defined field of view was used in Houdini to make sure that the 3D fortress scenes always match the original 2D image when looked at through the camera's perspective. As you can see in the photo to the right, the hills are translated back in a certain direction based on the vector between the position of the hill in the original image and the position of the camera. Objects also have to get larger as they're moved back, so they appear to be the same size in the camera view. The camera was also used to texture all the buildings by using the perspective of the camera and the original image as a texture, as Jasmine mentioned. Another important use of the camera was to experiment with multiple field of view angles that Duarte de Armas might have had when making these fortress drawings. As you can see in the video, the field of view is changed from 60 degrees to 80 degrees. As a result, the hills spread apart horizontally and the camera moves closer to the hills.
The final step of our workflow is the Unreal game engine. Unreal is a commonly used engine famous for games like Fortnite. We used Unreal to add interactivity to our toolkit, mainly the first-person perspective, which you'll see in the next slide. What allowed us to go from Houdini to Unreal is the Houdini engine plugin for Unreal, which is a common workflow for VFX artists and game designers. Here you can see what the Unreal interface looks like. The video shows a player moving around the reconstruction of a map of the fortress site Melgaço in Portugal. The toolkit allowed us to recreate the scene based on annotation data and minimal user input. Walking around the scene, you can see that the architectural objects like houses and towers are textured with the map itself. Experiencing the map in this way reveals some strange features, such as a comically large flag and houses that probably shouldn't be visible based on the map's perspective.
The purpose of making the Houdini digital assets that can be imported into Unreal is to make a toolkit that scholars can use to build these fortresses in ways that correlate to their source images. Here you can see a partially edited fortress scene in Unreal in the center, and our curated list of editable attributes in the Sandcastle Toolkit on the right. To edit the fortress, I first look at what we call the calculated keep position. This is the number in meters that the keep, which is the biggest and most important tower in any fortification, must be moved away from the camera in order for the 3D keep's width to match Duarte de Armas's measurement that he recorded in the Book of Fortresses. I can then use this value to estimate how far back the neighboring houses, towers, and hills need to be based on their relative position to the keep. These architectural features are moved back using a distinct instance number that signifies which hill or tower to move back. So as you're going to see in a second, the edit group range is number 3 to number 3, and the Z translate is 5, meaning that tower number 3 is going to be moved back an additional 5 meters. You can also see the numbers being displayed for the hills at the moment, so the user can easily identify which hill correlates to which number. The walls that Ali worked on can also be edited by the user by modifying the curve that the wall follows and changing features such as the height and the thickness of the walls. So as you can see in the video, when one of the points of the curve is moved, the wall recooks to fit that curve, as you can see right now.
The primary goal for the Sandcastle Toolkit is to enhance our spatial understanding of maps and city views from the early modern period through procedural translation of these images into 3D scenes. This means that research into procedural texture mapping and terrain simulation that was begun in Code Plus must continue. The project is also at an exciting stage for further development in the Unreal game engine. Currently, once a scene is built, user interaction is limited to walking around a scene as if you were the cartographer creating the map. In the future, the toolkit can be improved by adding more interactivity in Unreal, such as a mini-map that shows the avatar's approximate position on the original drawing, a virtual reality version of the scenes, or a horseback riding function that truly allows the user to explore the scene as if they were Duarte de Armas himself. During Code Plus, our efforts were geared toward the maps of the Book of Fortresses, but in the future we would like to see the toolkit applied to a wider range of city views from the early modern period, such as the annotated view of Lisbon seen in the center. That's the end of our presentation. Thanks so much for listening. We'd like to thank Code Plus and our sponsors again, and Side Effects for answering our questions that we had along the way. And we would be happy to take any questions you have now.
Wow. Well, I don't even know what to say. It's amazing. I was just chatting with Ed and I said, my brain hurts in such a fabulous way. Like I'm trying to wrap my brain around this. This is awesome. Ed, how do you, or team, how do you envision this impacting the future of curriculum using Houdini and tools like this?
I think I can answer just the curriculum thing, and I'll ask the students what they think. I mean, there's a couple of ways I'm imagining this in the future. Is I teach a course on historical GIS, so we're looking at this as a kind of an alternative to that, and so maybe potentially putting the Sandcastle Toolkit in front of people, students that don't necessarily, they can adjust some of the parameters, but they don't necessarily need to be people who can understand how to 3D model. In that sense, and so they can visualize these images in a classroom setting, or researchers can do a similar thing once we kind of work out some of the kinks on that. But for my other course, I have another course in which I teach the history of castles, and one of the final project actually is students get to design their own fortification, and so part of this, making that process of modeling easier, sort of unlocks their sort of creativity and their ability to use procedural modeling in ways to really look at more examples of fortifications and allow those to sort of influence the kinds of things that they build. So those are the two ways I'm looking at it, but I'd love to hear what the students think.
I can say something. I think this has a really great potential to bring something new to the discussion too, because anyone can look at one of Duarte de Armas's drawings and see the distortions, but the way the toolkit works is when you look at the values that you have to put in and you walk around and see what it looks like, it kind of adds all of these numbers to it. Like you get a number for what the field of view might have been, and you get a number for like how far that keep would have been pushed back. So kind of like add some numerical data that you wouldn't have if you just were looking at the photos and analyzing them in a classroom.
I would love to hear from David, who actually was a co-lead on this project as well as the museum project we saw earlier this morning.
Yeah, I think the most interesting thing I learned this summer is I always, came up through the world of computer science and viewed myself as working on, just code. And so I kind of focused on Unity and have started to look at Unreal. And I always just assumed, oh, modeling is just Maya, 3D Studio Max, SketchUp, kind of these other programs. But Houdini, I've learned, occupies kind of this interesting middle ground because you're using kind of this visual coding and sometimes actual Python and Vex coding to kind of construct the world and do the texturing. And so I guess it's shown me that a lot of these things can be done kind of with the mindset of a computer scientist and not necessarily of a 3D modeler. And what I'm taking away from this is I'm actually going to be, as part of the Roots courses, I'm going to be teaching a 2-hour workshop on it this fall, and hopefully making that part of something that at the CoLab we have an entry point for people who want to learn this Houdini tool, which, like I said, has just gotten on my radar this summer thanks to Ed and Mark.
That's fantastic, David. So
Thank
there's
you.
a question
There
in the chat, wondering if any of the team members are coming from an art history background. No art and visual media studies, folks.
I can jump in quickly. Jake and I both worked on the Vast Connections team over the years. So we got to, Jake worked more on Houdini, but for the first semester, we spent a lot of time reading about this particular project, the historical background there. So it was exciting to get to work on some of the technical part. And I think Jasmine is a VMS major or visual media studies major. I'm getting the minor. And so having taken like Intro to Digital Humanities, this was really cool to get to see how virtual spaces are working their way into not just these like highly technical projects that we think of in industry, but also into academia and education, because there is this big push there. I don't know if Jasmine wants to say anything.
Yeah, I was just gonna add that I actually was in the same class as Ali, and Ed came into our class as a guest speaker and was talking about this project, and Ali had already worked on it, and we found out we were working on it together. So it was just a really cool experience to be able to take what we were learning about spatial understanding and being able to recreate a scene that is taking up space in not only the maps, but in the actual landscape of the area that Duarte Armas was traveling around at the time. So although we don't have like art history background, this summer we kind of got to understand more about architecture, and I know what Merlins are now, matriculations and parapets. So that's just another cool way to be able to learn more about these architectural sites and very impactful historical sites.
Thanks. Thanks, Jasmine. There's another question from a student in the chat from Sonia.
Yeah, I can say something about this. I don't know if there was a specific point along the 10 weeks where I became like comfortable fully with Houdini, but I would definitely say when the project started, it was very, very daunting and confusing. But like we mentioned in the presentation, one of the first things we did was do a series of tutorials that were essentially just mini projects. And that really helped. But the main thing that just got us more comfortable was just really diving headfirst into the project after doing those tutorials. And it was definitely difficult at first, but just forcing yourself to, look at the software and do things and test things out until you just like naturally have these aha moments, I think is the best way to like understand a software like Houdini that is initially seems very complex and difficult to use. But so I would say just throughout the 10 weeks working on the project, it became more and more comfortable. And definitely now I feel like I can do a lot of things with the software that I definitely would not have been able to do towards the beginning of the program.
Yeah, and another comment from Mark there, complimenting you guys.
I think these were the two art-related projects were the two that were the most students were on site. Is that correct? Or in person, I think, right?
There were quite
Yeah, we did have quite a few.
Okay.
Yeah, we broke down about half and half just in the Sandcastle project alone, I think, between the two of us. Yeah, so we had this kind of interesting cohort. We tried a Zoom room and we eventually ended up with a really interesting process where there were probably 4 sub teams in different rooms constantly all the time. So it was really interesting.